All right, we're going to move on to a topic that you use every single day of your life, but you don't realize it. Okay, it's called absolute value. And the idea in absolute value is that when we work with numbers in the real world, we want them to be positive. So if you go to a store and you want to buy a certain item, okay, and you realize that after buying that item, it costs $4. That means that your payment was actually negative $4 because it was coming out of your account. But in your mind, you automatically flip that negative 4 to make it positive because when you're working with numbers, you want them to be positive. That's what absolute value is. The idea here being that if I have the absolute value of some number x is equal to 8, that means that this number x can be 8 because the absolute value of 8 is 8. But it also means that x can be a negative 8 because the absolute value of a negative 8 is going to be equal to 8 as well. Absolute value, these bars, simply take a number and you make it positive. That's it. Okay, so over here, y can be 2 and y can be negative 2 because the absolute value of negative 2, those are what those bars are equal to 2. And down here, this is where it gets a little tricky because I want to show you what a graph of absolute value looks like. So let's say we're going to just make the absolute value of x, just some number, okay? And this is what an absolute value graph looks like, is that it's going down, 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 and it hits this number, 0, and then it pops back up. If we look at a table, we'll get the same type of idea. Okay, so it gets down to 0, but then it goes back up. Absolute value forces a number to be positive. Therefore, down here, the absolute value of some number c is equal to negative 3 is impossible. Because the absolute value of a number c would have to be positive, just like we saw up here. So it's impossible, so there's no solutions. Okay? What we're going to be working on today is when you work on absolute value, because it forces numbers to be positive, inside of these bars can be positive and negative answers, but they're both going to come out to be a positive 5. So that means we will have a positive and a negative side of inside these bars. Okay, the positive one is super easy. You just take this and you rewrite it without the absolute value bars. X minus 2 equals 5. Nice and simple. However, the negative one gets a little bit trickier. We're going to take this thing in here, we're going to leave it the same, and the opposite side, this, is going to be made negative, or the opposite. So if this was a negative 5, it would flip. Okay? So for this one over here, we go x equals 2, or x, add 2, sorry, x equals 7. And over here, we're going to add 2. And so x equals negative 3. And the confirmation of this should be pretty easy. We just take our thing, we go 7 minus 2. We get the absolute value of 5 equals 5. And over here, we do negative 3 minus 2 equals 5. Well, the absolute value of negative 5 does equal 5. So those are both good. Now they get a little bit trickier. So we have positive and negative on both sides. Positive one, still the same. 3x minus 3 is equal to 6x plus 12. The negative, though, we go 3x minus 3. We have to make everything negative on this side. So we get negative 6x minus 12. It's like taking the whole term times negative 1. So we have to make both terms negative. And then we just solve from here. So I'm going to subtract 6x. And I'm going to add 3. I'm going to combine them together because you guys have done these a lot. 15. We divide by negative 3. x equals, whoa, don't do that. -5. And over here, same thing, we're going to add 6x. We're going to add 3. So we get 9x equals -9, because that's -12 plus 3. And we divide by -9, x equals -1. And then you check your answer. Okay? One last thing I got. Oh, there's one I wanted to show you somewhere. I don't know what happened to you. Where is it? Here it is. Okay. So for this one, we want to do the positive and the negative trick, but there's a problem. The absolute value bar is not by itself. Therefore, we have to add 6 to both sides before we start anything else. So we get 2x minus 3 is equal to +6. And now we can do the positive negative trick to get rid of the absolute value bars. I would like to point out too that with these bars in a problem, you can't solve it. You have to do this trick to get rid of them. So we get 2x minus 3 is equal to 6. Over here we get 2x minus 3 is equal to -6. So we add 3. 2x equals 9. Divide by 2. X equals 9 over 2, or 4.5. And here, we get 2x is equal to -3 divided by 2. And so x is equal to -3 over 2, or -1.5. Okay? There you go. Now I'd like you to try these on your own. This one up here, the positive answer should be c equals -3, and the negative answer should be c equals -11. Down here, we have to add 4 before we start. And so you get 2x plus 2 is equal to 8. Oops. So the positive answer should be x equals 3. And the negative answer should be x equals -5. If you have questions on either of those, please bring them in to me and I will help you. The assignment will be posted online.